Hey everyone, I'm just going to be going over the RTOS Worksheet solutions. So to start off, we're asked what is the total utilization of the set of task A, B, and C. To calculate the total utilization, we have to calculate the utilization of each individual task and then add them. So for task A, it would be 1 divided by 5, the execution time divided by the period, which would give us 0.2. For task B, it would be 0.286. And for task C, it would be 0.25. When we add them all together, we get the answer for part A, which is 0.735. Then after this, we are asked to see if the set of tasks is schedulable. To check, we use the following formula. UN equals n times 2 to the 1 over n minus 1. In this case, n represents the number of tasks. So for our case, it'll be 3. Which gives us 0.7797. And we know that it is schedulable because this number is greater than 0.735, which means that it is schedulable. It then asks us to identify the highest and lowest priority task when using rate monotonic priorities. When using rate monotonic priorities, the highest priority is the task that has the lowest period. So we will have C, then we will have A, and then B. It then asks us to draw the timeline, starting all 3 tasks at time 0. So I organized them based on priority. So I have C right there. I'm just gonna draw down the period. So we have C with a period of 4, A with a period of 5, and B with a period of 7. C and A both have an execution time of 1. So first we'll do C, then A, and then B, which has an execution time of 2. So it is clear that they are able to be scheduled. Part E asks us to add 1 unit to the execution time of task B, so that'll be 3, and recalculate the utilization. So we have 1 over 5, so that's 0.2. Then we have 0.429, because we have 3 over 7, and 0.25. We add them all together and we get 0.879. We know that U3 is 0.7797, and this is not greater than the total utilization, so this is not schedulable using the UB test. We'll do the same thing with the timeline. Again, we have the same periods, that hasn't changed. And basically the same thing for C and A. But for B, it changes because we have 1 more execution time. So it'll look like this. And this just shows that it is still schedulable and the utilization bound test is sufficient, but it's not necessary. So for part 2, we're asked to assess the schedulability of the following task set. And we have task A, B, and C. I've labeled task A to be 1, task B to be 2, and task C to be 3, just to help us with what comes later. So we first have to assess the schedulability of task A and B, since they're the higher priority ones, as they have the lower periods. So that would be 1 over 5 plus 3 over 6, that's 0.7, and that is less than the utilization of 2 tasks. For task A, B, and C, it is 0.7, as before, plus 3 over 14, and that gives us 0.914, and that is not less than the utilization of 3. So this means that the utilization bound test has failed, and we have to do the RT test. For the RT test, we start with A0, and we're doing the RT test for task C, or 3, as I've chosen to call it. So we're going to replace the I here with a 3. So essentially what we're going to do is sum up the costs of task 3 and all the higher priority tasks than task 3. So it'll be 3 plus 1. So in another way to put it, this will be the cost of C, the cost of B, and the cost of A. And this will give us 7. Then for an plus 1, which would be in this case 1, where n would be equal to 0, we would have a1 equals cost of 3 plus 2 equals 1. A0 in this case, EJ and CJ. So if we expand, it'll look something like this. we plug in what we know. So we have that task 3 has a cost of 3. We know A0 is 7. And we know A0 is 7 again. You know what the period of task 2 is 6 and 3. What this symbol means is the ceiling of whatever the division inside is. So we'll have something that looks like this, which will be 11. Now we want to do the next one because 11 and 7 don't match. And I think I forgot to mention, but the test ends when there are 2 consecutive A's, so let's say AI and AI plus 1, that are equal, and that they're equal, the number at which they're at is less than the period. So in the case for our task, it has to be less than 14. So now we're going to do A2. It is the same format, so we're going to have this, but the only difference is that we're going to have A1 now instead of A0. And just to simplify things, I plug in and I get 12. And we do the same thing for task 3. Sorry, for A3. We have 12 and that doesn't match. That's why we go to A3. And we're going to actually, in this case, get 12. You can plug in, you can run this on your own, and you'll see that once you plug in, you'll get 12. So now that we know that it matches, we check if it's less than the period of the task we're calculating this for. Period is 14, so this means that task 3 is schedulable. Task C is schedulable. So for question 3, we're asked to build a schedulability model for this task set here with the extended UB test explained above and the RTOS test if necessary. So I'm just going to explain what this test does. This is a replacement for the UB test, since we now have preemptible and we have tasks that are preemptible and that also can be non-interruptible. So we have basically 3 parts here. So for the first one, this is the set of tasks HN, and the set of tasks HN contains the tasks that have a lower period and a higher priority than the current task, which is task I. And the tasks in H1 are the tasks that have a higher priority and a higher period than task I. So in the case of, let's say, task 3, right, the ones that would be in HN would be task 1 and task 2, because the ones in HN have a lower period, so 10, 50, and 75 are less than 100, and they have a higher priority. High and medium are higher than low. And the one that would be in H1 would be the interrupt, because it has a higher period and a higher priority. So we will start with calculating these for task 1. So task 1 doesn't have any tasks that are have a lower period than itself. So we have nothing in HN. So this will just be the center term right there. And we will have 1 in the H1, which will be the interrupt, which will be like this. We don't put the period of the interrupt in this one, at least for tasks in H1. We actually just use the period of the current task, so TI. So we will use 50. And to find the utilization bound that we're going to use, we have to recalculate the N with the following equation right here. So it is the number of tasks in HN plus 1. There are no tasks in HN for this particular one, so we just have a N equal to 1 for this one. So we check if this is less than U1, which is just 1. And let's see if that's the case. And I think that is the case because we have 0.2 plus 0.3, and that is less than 1. So for task 2, we now have a task that is in HN because task 1 has a lower period and a higher priority than task 2. So we will include it here. Again, this is this term. And then we have itself. which is 10 over 75. And then we have 15 over 200 over 75 here. And this is equal to 0.2 plus 0.13 plus 0.2. And now we have a task in HN, so n is going to be 2. So the utilization bound is going to be 0.878. And this is still less than that. So task 2 is schedulable. Now for task 3, we have two tasks, 10 over 50 and 10 over 75, that have a lower period and a higher priority. And we have itself, the center term, which is 40 over 100. And we have the interrupt, which is 15 over 100, again, because we're using the period of the current task. And this will be equal to 0.883. And we want to check if that is less than the utilization bound, which in this case would be 3. And that will give us 0.797. And that is not, so this does not pass. We can also do the one for the interrupt. And there are no tasks that have a higher priority in it, so it'll just be by itself. And there are no tasks in HN, so that's just going to be a utilization bound of 1. And that does pass in this case. So we're going to have to use the RT test because task 3 resulted inconclusive. So we're going to start with A0. And for A0, we have 3 tasks that have a higher priority. So we have task 1, task 2, and the interrupt. And we're going to get the costs of each. So the cost of each and itself. So we're going to have 10 plus 10 plus 15 plus 40. And this would be equal to 75. So now we will proceed to go to A1. And A1 is going to be the following. So we are in task 3. And we're going to have the sum of the tasks that have a higher priority. T0, Tj, Tj. So this will be equal to 40 plus 75 over 50. 10. This comes from task 1, right? We have a period of 50 and an execution time of 10. We have 75 over 75. This comes from task 2. And again, remember that we plug in A0 in there. That's why it's 75. And we have 75 over 200 because this is the interrupt. And what this ends up giving us is the following. So we'll have 80 plus, we have 60 plus 25, which is 85. And this does not match with what we had here, so we will go ahead and do a 2. And a 2 is practically the same as a 1, but the thing that changes is that we now have 85 instead of 75 plugged in. So here we will have an 85 instead. And what this will yield us is a 95. Again, the thing that changed in this one was that we now have 85 over 75 rather than 75 over 75. So this is a 2 now. So that will be a 95. We will do the same thing for A3 because this does not match. And if you do it, you'll see that this will result in 95, and it does match. And now we want to check if it's less than the period. And that is the case. So task 3 is schedulable. Part C asks us to split the, apologies, to task B asks us to compose task 3 of 2 sections. We have 3A and 3B, and their execution times are 30 and 10 respectively. and 3A is non-preemptible and non-interruptible. So we have to set up the UB test for this case. So let's start with B. So for task 1, again, there are no tasks that have a lower period, so we're just going to have the following set up here. The interrupt, and we're going to have, in addition to that, we're going to have the cost of 3A. Because 3A is non-interruptible and non-preemptible. And we're also going to have a utilization bound of 1, because we did U1, there are no tasks in HN. So what this will give us is 10 over 50 plus 15 over 50 plus 30 over 50, because 30 is the execution time of task 3A. And this will give us 0.3 plus 0.3 plus 0.6, 0.2 plus 0.3 plus 0.6, which is greater than 1, so this fails. We'll do the same thing for task 2. Again, we have a task that has a lower period and higher priority itself, and the two that are in H1, so the interrupt and the 3A. And this is actually, we're going to test it if it's less than the utilization bound of 2. And this fails. You can plug in and you'll see that it's less, so it's greater than. We'll see now for task 3. For task 3, it's interesting because we have the same, we have cost, the 2 in HN. So task 1 and task 2. We have itself, but we only have the interrupt in H1 because we are dealing with task 3. So we don't have to put it there, as task 3 can't preempt itself, so, or it can't also be non-interrupt itself really. So we're gonna test it against U3, and that's gonna fail. It failed the same way as before. And for the interrupt, we actually now have something that can interrupt it, or that can kind of block it. So we're gonna have cost of I and Ti, and we're also gonna have the 3A now with this one. And this will be equal to 0.075 plus 0.15, and we want to check if that is less than 1, and it is. So the interrupt is schedulable, but task 1, task 2, and task 3 apparently are not. They didn't satisfy the extended UB test. So now we're asked to perform the RT test on task 1. So in this case, we want to go with all the higher priority tasks than it, and that'll be itself. So task 1 is this one, the cost of task 1. We're going to have the cost of the interrupt, and we're going to have the cost of the 3A. And this will give us 55. And 55 is actually greater than the period of task 1. So this means that it is not schedulable at all. For 3D, we break up task 3 into 2 or more smaller non-preemptible blocks of time. So we're going to have 3A being split up into 2. We have 10 and 20 in this case right here. And we're going to have to develop an equation, an inequality for task 1. So what we're going to have is same as before. There are no tasks that have a smaller period than task 1. We have the interrupt, same as before. But now we're going to have the maximum between 3A1 and 3A2 over task 1. And this will be compared to the utilization bound of 1. And based on the maximum of these two, we will see if it is schedulable or not, or at least if it passes this particular test. For the example we have that 3A1 is 10 and 3A2 is 20. So the max of that is 20. So we're just going to plug in what we have. And this is equal to 0.2 plus 0.3 plus 0.4. And that is 0.9, which is less than or equal to 1. So in this case, it is schedulable. Not as before, where it was not. And that's because now we have to choose between two maxes right here. So guys, I made a little mistake. I did put here during my explanation, I did put a task 1. But this is the RT test, so this is just A0. So just so you don't get confused, I put this in the end of the video.